Okay, the salaries of Jackson High School teachers, is that qualitative or quantitative? Quantitative. It's a number, right? The number on the doors, entrances at the high school. Still a number, but it is qualitative because it's labeling the doors. If a number is used just as a label or you're assigning a number to somebody, that's qualitative. All right. Determine what level of measurement. The weight of a letter. Ratio. Can we say this letter is twice as big as heavy as this letter? Yes, so it's a ratio. The top 5 ranked wrestlers in Ohio. Ordinal. We're ranking, right? You can't really divide them. Okay, average age of students in statistics class. Descriptive, right? We're just describing them. Past figures, it's predicted that 82% of the students who do not study will fail CCB stats. Right? Inferential. We're making a prediction. It's probably higher than that. Since we haven't had CCB stats, we really can't say that statement at all. Okay. So, today we're going to talk about data collection and experimental design. Again, there's a lot of just writing definitions and writing stuff in this first chapter. I apologize for that. I know you want to do stuff with numbers, but it is what it is. Okay? You do have a Math Excel in this section, and it is due on the 27th, which is tomorrow. And normally I don't make them due the next day. So you have today and tomorrow to work on them. But why am I making it due tomorrow? Because you have a quiz on Wednesday, and if you haven't done the Math Excel or practice at all, it's not going to go well. So I'm going to do that. All right. So here we go. Steps to designing. You identify the population or variables of interest. And what are we looking at? What are we trying to study, right? Develop a detailed plan for collecting the data. So how are we going to collect the data? Collect the data. Describe the data using descriptive statistics. Interpret the data and make decisions about populations using inferential statistics. And identify any possible errors and make recommendations to make the study better or the experiment better. Okay? Next chapter, there is a project that you have to do, which involves designing a study of some sort. Okay, so these are things you have to keep in mind when you're doing that. We're not going to cure cancer or anything in this class, but it'll be a basic project. Okay. So we need to identify the population and variables of interest. What do we want to study? We have to figure out how we are going to do it, how we're going to get our data. We have to actually do it. Be able to describe our data using descriptive statistics, maybe charts, graphs of some sort. And there's no sense in collecting data unless you're going to use it to interpret or make decisions with it. And you should always look for any possible errors that might have occurred. Okay? Okay, observational study. So there's two main types of studies. You have an observational study where you're just checking out characteristics or interests of the population. So you can, for instance, measure the amount of time you spend watching TV, or the amount of time you spend watching YouTube videos, or the number of Snapchats you send in a day. These things could get crazy, right? So that's an observational study. We're just watching you and seeing what you do. Making tally marks every time you do something. Okay? Just through observation. Okay. And then the other type of study would be an experiment. So in an experiment, you have a treatment that you're applying to part of the population. That's called the treatment group, and obvious. And you observe how they react to that treatment. You try to get them to quit smoking or sleep better. Okay. Another part of the population may be used as a control group. Those are the people that you give a fake treatment to, a placebo. So they think, and then you're going to see. Okay? A placebo is a fake treatment. It looks like the real thing. How many times when you were little that your mother put a Batman Band-Aid on your finger even though there really wasn't that much there that you needed a Band-Aid for? But it made you feel better, right? Batman Band-Aids are placebos. Okay. So the treatment groups get the treatment. The control group does not get the treatment. They're in the study just as a control. If they're given anything, it would be a placebo. So back in elementary school, you maybe grew plants, and one you tried to put extra water or something to see if it would grow better, and one you just watered regularly. So you'd have a control group where you just treat normal, and the treatment group you're applying what you're trying to study the effects of. Okay? All right. So observational study versus experiment. Which is which? So the first case, researchers study the effect of vitamin D supplementation among patients with antibiotic deficiencies. To perform the study, 70 patients receive 4,000 IU of vitamin D daily. Another group of 70 receive a placebo. Is that a experiment or an observational study? Experiment, right. Easy breezy. Researchers conduct a study to determine how confident Americans are in the U.S. economy. They call 3,040 adults and ask them to rate current economic conditions. Observation, right. You're just doing a survey. Okay. All right. So how are we going to collect data? We can do a simulation or a survey. These are two ways to get data, simulation or survey. If you're doing like a observational study. All right. So in a simulation, we're using math or physics to reproduce conditions. These are things like crash test dummies. You don't actually use the car and real people, right? You simulate something that are impractical or dangerous to do in real life, right? This is going to use computers, all sorts of stuff, all right? Simulations save time and money. Okay. A survey, you know what a survey is. You're going to mail a survey, you're going to talk to them on the phone, you're going to knock on their door. email them. Okay. So survey's pretty basic. So the key elements of experimental design are control, randomization, sample size, and replication. Okay, the control is very, very important. You want to control your experiment, because if you don't have a good control, then you don't know what's actually causing the results. Okay. So we're going to go through each one of these. Okay, the first one is control. You're controlling for effects other than the one being measured. All right? So if you have confounding variables, it means you're not sure what caused the result. So for instance, a coffee shop owner remodels her shop at the same time the mall has its grand opening. So she notices the coffee shop business increased. But what increased the business? Was it her remodeling, or was it the new mall that opened? So those are confounding variables. You can't tell why she had more business. Okay? So confounding variables is when you cannot tell the difference, the effect of one variable over the other variable. Okay, when you have different factors that might be affecting the change. That's confounding variables. All right. Placebo effect. A subject reacts favorably to the placebo when in fact he or she has been given no medical treatment at all. So that happens. Okay? So you want to do a blinding technique. So you don't know whether you're getting the placebo or not. Okay? If it's a double blind, not only do you not know, but the experimenter guy who's in charge doesn't know. Because sometimes if you know who's getting the placebo, you might act differently towards them. Okay? They may notice a little difference of how you're treated if you know they're getting a fake drug. Okay? So a double blind, neither the subject nor the experimenter knows who's getting the treatment and who's getting the placebo. Okay. Okay, so know those words. Placebo effect is when the subject reacts to the placebo. Blinding is when nobody, or the subject does not know whether they're getting the placebo, and the double blind is nobody knows who's getting the placebo and who's getting the real treatment. Okay? All right. So that's all control. Randomization is a process of randomly assigning subjects to different treatment groups. So there's lots of ways we can do this. So completely random, just through a random selection, number generator, or whatever. Okay, that's completely randomized design. So in your treatment group, you're just randomly selecting who gets the treatment. Randomized block design. So you divide subjects with similar characteristics into different blocks. So in this case, these are done by age. So you get your 20-year-old block, your 30-year-old block, your 40-year-olds, your 50-year-olds or above. So you group them by age first. And then within that block, you randomly assign whether you're getting the treatment or you're getting the control placebo or whatever. Okay? So they're going to break them up into weight or into age, and then they'll randomly assign subjects to either the treatment group or the control group. Okay? So when you're blocking, you're separating first by a common similar characteristic. Then you're splitting randomly with control or treatment. Okay, matched pairs. Subjects are paired according to a similarity. So maybe they're both males, maybe they're both white, maybe they're both in their 20s, whatever. So they're called matched pairs. You're pairing them up, and then one of them gets the treatment, one of them gets the control. Okay? Or in this case, they gave them two different treatments. And then they're going to see how they work. This is used a lot with twins. Okay, so very similar people. They give them two different treatments or a treatment or control. All right. So if you can find a similarity to pair them with, and then split them. Okay, replication. It's the repetition of an experiment using large groups of subjects. So it needs to be able to be replicated for the results to be more valid. Okay? So to test a vaccine against a strain of influenza, 10,000 people are given the vaccine, another 10,000 people are given a placebo. Because of the sample size, the effectiveness of the vaccine would most likely be observed. The more people you have in your experiment, the more valid the results are. You're going to be able to see something, okay? You can see replication. All right. Sample size, huge. N must be a large enough number to detect differences worth detecting. Okay, this is a huge part of the experiment. Surveying 5 people does nothing, right? If it's too large, it's wasteful, potentially costly, and risky for sampling units. Okay? Too many people. Also bad. So if it's too small, effects will be missed. So a good sample size, guys. And we'll talk about that more in depth later as to how to pick that. So we're going to look at some experiments and determine what might be wrong with them. Okay. A company wants to test the effectiveness of a new gum developed to help people quit smoking. Identify the potential problem with each experimental design and suggest a way to improve it. Wait. After 4 months, most of the subjects in the treatment group have quit smoking. So what's wrong with this? Yeah, you've got two variables, right? What's keeping them from smoking? Is it the gum, or is it watching the DVD of people's jaws rotted off? I mean, you know, there's confounding variables there, all right? So you need to pick, either split it into two different subjects or studies, or give one or the other, okay? All right. So different kinds of sampling. You have the random sample where every member of the population has an equal chance of being selected. So these are the different ways to sample, or different types of sampling. And you want your experiment to have random sampling of some sort. Okay? Simple random sample is every possible sample of the same size has the same chance of being selected. Okay. All right. In the simple random sample, random numbers can be generated by random number table or a software program or a calculator. So after my calculator starts working, this is how we will pick the cell phone of the day. I already randomly picked them earlier, but this is a good way to do it. Okay? Assign a number to each member of the population. Phones. Members of the population that correspond to these numbers become members of the sample. Okay, so we're only picking one to be in our sample for that case. All right. There are 731 students currently enrolled in statistics at your school. Not true. If you wish to form a sample of 8 students to answer some survey questions, select the students who will belong in the sample, a simple random sample. So you're assigning the kids to 1 through 731. On the table of random numbers, choose a starting place. Suppose you start in the third row, second column, and we'll do this. And then it just randomly generates every 8, or they divide by 8 and they count it. Okay, so that's random. Okay. A stratified sample is you're dividing the population into groups and select a random sampling from each group. So notice the groups have something in common. So you have low income, middle income, high income. All right. So you've got to think of stratosphere and the different levels of the atmosphere. So this is an example of West Ridge County households. They're in socioeconomic levels, so low, middle, high, and then notice so many from each get picked. Okay, so that's a stratified sample. A cluster sample, divide the population into groups and select all of the members in one or more, but not all of the clusters. So they're dividing them into zip codes in this case. And then all the households in that zip code it's surveyed. Okay? Not all the zip codes, just that one zip code. Okay? So that's a cluster sample. All your samples clustered into one little set area or set group. And some of these sampling techniques are better than others, depending on your study. Okay. Then you have systematic sampling. So again, you're starting at random starting spot and then choosing every K member of the population. So you could list the house numbers and choose every 100th house or whatever, but you're randomly starting. Pick a spot and then count from there. Okay. Convenient sampling. Choose only members of the population that are easy to get to. This is not a good way to do it. Okay? That's where you're going to get the bias. If you're in choir class and you're doing a survey on people's favorite type of class at school, are you going to get more people wanting the arts or more people wanting woodshop or math or something like that? Okay, so you have bias there. If I asked you a question, if we did a survey out in our parking lot and the question had to do with how much your first car costs, do you think our average car in our parking lot is probably more than, let's say, Massillon's parking lot? You see, I'm biased. That's not going to be a generalization we could say to Stark County teens. Okay, so it depends on the survey you're setting up, the study you're setting up. But we are not typical Stark County teens. Neither is if you just set it in Massillon. So where would be a good place that you get a nice random sample of Stark County teens? Where do you guys go? Snapchat my bedroom. Where do you guys do? What do people do? Swenson's? The mall? You guys still go to the mall? No? How about Tinseltown? Go to the movies? Maybe the movies? I don't know what you people do. What do people do for fun? Swenson's. But again, Swenson's is sitting right in Jackson. That's the problem. Yeah, it's crazy. All right, here we go. I'm gonna skip it. Let's skip it. Let's identify a sample. We've got 2 slides, and we're gonna be done. You're doing a study to determine the opinion of students in your school regarding stem cell research. You divide the student population with respect to majors. This is a university, and select and randomly select and question some students in each major. So what did they do? Which sampling do we have? Is it just completely random? Stratified, right? We divide it up into majors and then randomly picked. Yep. All right. Let's do another one. You assign each student a number and generate at random numbers. You would then question each student whose number is randomly selected. Simple random sample. Systematic means you start at a certain number and then go every so often, like every 10th kid in the list. Okay? here you're just basically, everybody has a number and you're randomly picking those numbers from a computer-generated program. Okay? Make sense? All right. So